Hello everyone. So we were doing chapter of matrices or linear algebra and the topic was rank. In the previous session we have done rank by minor method and today we are going to start with the elementary transformation method. Okay. So the first question which we are going to do today is find rank of matrix A by elementary transformation, and the matrix what they have given is A is equal to 1 3 2 4 6 5 3 5 and 4. Okay, so this is a 3 by 3 matrix and we have to find the rank of this matrix, but we can't use minor method, we have to use elementary transformation. So when they have asked us to find the rank of a matrix, so basically we need to apply row transformations. Okay, so because our concern is with non-zero rows, number of non-zero rows. Okay, so the very basic and first step should be first row first element should be 1, and in the given matrix it is already given to you 1, so it is a plus point for us. So our first operation will be to make this element and this element to be 0. So that means I am operating on R2, that is R2 minus, now I have 1, so that means I should multiply 4 with R1, and in case of R3 I have 3 over here, so that means 3 should be multiplied by R1. Okay, so the matrix reduces to 1 3 2, that will remain as it is. Now 4 minus of 4 0, 6 minus of, now R2 is 6 minus 4 times R1, R1 is 3, so that means 6 minus 4 3 is a 12, so it will be minus 6. The next element we have 5 minus 4 times 2, so that means 5 minus of 8, that is minus of 3. Now in the next step what we are having 3, so that means 3 minus 3 times R1, 3 times R1, so it will be 0. Now the next step will be 5 minus 3 times again 3, so it will be 5 minus of 9, that is minus 4. And the last element what we are having, that is 4 minus of 3 times 2, so it will be 4 minus of 6, that is minus of 2. So this is the first step. Now we have received these two elements as to be 0. Now next step will be to reduce this one as 0, and step by step this is to be 0. So the very next step after this one, what should I do? I divide this row by 2 minus 2 and this row by minus 3. So R2 tends to minus 1 by 3 R2, and second operation will be on R3, that is minus 1 by 2 of R3. Okay, so the new matrix so formed will be given by 1 3 2 0 divided by 3 0, 6 divided by 3, that is 2 with a negative sign, so it will be positive 2, 3 by 3, that will be 1, last will be 0, the next element is 2 and last element is 1. Now just check, R2 and R3 both are identical, so that means it will be very easy for us now. Now we have to apply the operation that R3 tends to R3 minus of R2. So we got 1 3 2 0 2 1, 0 minus 0 0, 2 minus of 2 0, 1 minus of 1 0. Okay, so that means I have reached a stage in which I have obtained one of the row as 0 and 2 as a non-zero rows. Now do we have any method to make 1 and 2 0 also? No, we can't. Why so? Because if I try to make either 2 or 1 to be 0 by using R1, so this 0 will be eliminated. So that means it will be a non-zero number. So don't need to do attempt further. Now here we mentioned that number of non-zero rows is equal to 2. Therefore, rank of a matrix is equal to 2. And that's your answer. Hope it is clear. Now we'll take one more question. So similar question will be I'll be taking 3 by 4 now. Okay. So the question is, find the rank of the matrix A is equal to, now they have given us the elements 1, 2, minus 1, 3, minus 2, minus 4, 4, minus 7, then it's 1, 2, 1 and 2. Okay. Now in this matrix, first step will be rank of A will be less than equal to minimum of the order. Number of rows are 3 and columns are 4. So that means rank of A is always less than equal to 3. Okay. Now in the given matrix A, what we are having right now, 1, 2, minus 1, 3, minus 2, minus 4, 4, minus 7, 1, 2, 1 and 2. So basically it is a 3 rows and 4 column matrix. What is the basic step required for us? That the first row, first element should be 1 and it is 1 over here. So the first operation will be to remove this minus 2 as 0, R2 plus 2 times R1, and on R3 we'll apply R3 minus of R1. Hope by these operations are clear. Now moving towards the operation, 1 will remain as it is, 2 remain as it is, minus 1 as it is, 3 as it is because it is a first row, minus 2 plus 2, so it will be 0, minus 4 plus 4, 0. Now 4 minus 2, 2, minus 7 plus 6, that is minus 1. 1 minus 1, 0, 2 minus of 2, 0, 1 minus 1 is plus 2, 2 minus 3, minus 1. Again quite simple because here row 2 and row 3 both are same. So now what we have to do, we have to apply operation on R3, that is R3 minus of R2. So here what I am getting now, here it will be the operation 1, 2, minus 1, minus 3, 0, 0, 2, minus 1, 0, 0, 2 minus 2, 0, minus 1 plus 1, 0. Okay. So that means again we can't reduce this one and this one as 0, because if we try to reduce these two elements has to be 0. So what we got, we will not get these two as 0. Okay. So in that case, here the number of non-zero rows is equal to 2. Therefore rank of A is equal to 2. Okay. So one more question, because we want to have a maximum number of practice. So now we have the matrix A. Here we are having 1, 1, 1, 1, minus 1, 1, 2, 1 and minus 1, and we need to find the rank of A. We need to find it. Now the order of matrix is 3 by 3, so that means rank of A is less than equal to 3 because minimum of 3 is 3. Now the very first operation or the step should be to make this as 1. Here it is already 1, so the operation will be on R2, that is R2 minus of R1, and the operation on R3, that is R3 minus the number into R1. Okay, now first row to be remain as it is. 1 minus 1, 0, minus 1 and again minus 1, minus 2, 1 minus 1, 0, 2 minus of 2, 0, 1 minus of 2, minus 1, minus 1 and minus of 2, minus of 3. Okay, clear? Now what should be the next step now from our side? That we need to reduce more values. So what I do, so it will be better for us if we reduce this minus 2 as either 1 or 0. Okay, so what I do, I just basically apply the operation on R2, that is R2, that is minus half of R2. Okay, so what we are getting now from this step, we will be getting the result 1 1 1 0 1 0 0 minus 1 and minus 3. Now just check, by using this way I can make this one and this one as 0. Okay, so now operating on R1, that is R1 minus of R2, and on R3, that is R3 plus R2. So I will receive the value 0 minus 1 minus 0 1, 1 minus 1 0, 1 minus 0 1, 0 1 and 0. So now 0 0 and minus 3. Okay, now the next maximum step what I can do now, here I can reduce this minus 3, this element as to be 1. So on R3 it tends to be minus 1 by 3 R3. Basically the result has been obtained, but I am doing the expanded form. So what happens if students proceed for further steps? So we'll check that one. 1 0 1 0 1 and 0 0 0 and 1. Okay, now I'll operate on R1, that is R1 minus of R3. So in that case it will be 1 minus of 0 1, 0 minus 0 0, 1 minus 1 0. So 0 1 0 0 0 and 1. Now all the three elements which are existing right now with me, that is 1 1 and 1, they are in diagonal, so they can't be cancelled out in any case. So that means number of non-zero rows is equal to 3. So rank of A is equal to 3. I think so the concept has been cleared, or should we move further for one more question? I'll take a case of 4 by 4 matrix. Okay, this one will be the last question from this topic, and then we'll move towards the next normal form. We have a normal form also, but in the next class. Okay, find the rank of the matrix, and matrix is given to you as A is equal to 2 3 minus 1 minus 1 1 minus 1 minus of 2 minus of 4, that is 3 1 3 minus 2 6 3 0 and minus of. So that means it is a 4 by 4 matrix. Now for a 4 by 4 matrix, again same steps will be followed. Okay, so solution will be rank of A will be less than equal to minimum of 4 4. That is what rank of A is less than 4. Since we know that first row first element should be 1, but here we have 2, so we need to make first row first column to be 1. So what I do, either I can do, two possibilities are there, either I can reduce this 2 as 1 by subtracting R1 minus R2, or I can interchange both of the rows. So it will be better if I interchange the rows. R1 and R2 I'll interchange. So it will be now 1 minus 1 minus 2 minus 4, then 2 3 minus 1 minus 1, 3 1 3 minus 2, 6 3 0 and minus 7. Now I need to make all of the terms below 1 to be 0. These all terms to be 0. Okay. So these all terms will be made as 0 as if I take on operation R2, that is R2 minus 2 times R1, on row R3 that will be R3 minus the number itself 3 into R1, on R4 that is R4 minus the number that is 6 into R1. Okay, that is the simplest step. What we are applying? R2 minus the number into R1. On R3 I am applying R3 minus this number into R1. On R4 I am applying R4 minus 6, this number, that is 6 times R1. Okay. So what I am getting now for this one? I will be getting the value as 1 minus 1 minus 2 minus 4 as it is. Now 2 minus of 2, 0. Now 3 plus 2, 5, minus 1 and plus 4. 4 minus 1, 3. Then minus 1 and plus 8. 8 minus 1, that will be 7. On third row, sorry. 3 minus of 3, that will be 0. 1 plus 3, that will be 4. 3 plus 6, that is 9. Minus 2 and then 12. So what we are having? Minus 2 minus 3 times minus of 4. So it will be minus 2 plus 12. So it will be what? 10. And the last will be 6 minus of 6, 0. Next 3 minus 6 times minus 1. So it will be 3 plus of 6, that will be 9. The last it will be 0 minus 6 times minus 2. So it will be 12. And minus 7 minus 6 times minus 4. So minus 7 plus 6 4s are 24. So 24 minus of 7. So it will be 17. I think so. These steps are clear to everyone. Now after obtaining these steps, what I can do? I need to reduce this. Now just check 9 and 5 plus 4 is always 9. So that means I can use an operation R4, that is R4 minus of R3 and R2. Okay, 2 operations in single step. So 1 minus 1 minus 2 minus 4. But keep one thing in mind, when I am to solve R4 I am using R3 and R2. You can't apply any operation on R3 and R2 right now. You can apply on R1 but not on R2, R3. Okay, because they are being used. 0, 5, 3, 7, 0, 4, 9 and 10. So 0 minus 0, so it will be 0. Now 9 minus of 4, 5, 5 minus of 5, 0. 12 minus of 9, 3, then 3 minus of 3, 0. 17 minus of 10, 7, 7 minus of 7, 0. So I got a row which is completely 0. Okay. Now next, if I take the step on R2, R2 tends to R2 minus of R3. So what will be the result in that case? It will be 1 minus 1 minus 2 minus 4, 0, 5 minus 4, 1, 3 minus of 9 minus 6, 10 minus 7 minus of 10 minus of 3, 0, 4, 9 and 10, 0, 0, 0 and 0. Now I can make this one as 0. The steps have been completed, but if we move on to move further, so what will the next will? R3 tends to R3 minus 4 times R2. Okay, so it will be 1, minus 2, minus 4, 0, 1, minus 6, minus 3. So 0. Now 4 minus of 4, 0. Now 9 minus of 4 times minus 6. So it will be 9 plus 6 4s are 24. 24 plus 9, 33. Next is 10 minus 4 times minus of 3. So 10 plus 12. So it will be 22. And the last will be 0, 0, 0 and 0. Next step, I can divide the row third by 11. So I'll reduce R3 tends to 1 by 11 times R3. So it further reduces to 1, minus 2, minus 4, 0, 1, minus 6, minus 3, 0, 0, 3 and 2, then 0, 0, 0 and 0. Now just check, after applying any other the concept, I can't make any further zeros. Only possibility if I want to make a 0, so it will be if I multiply this row by 2, so 6 and 6 0, but that will be the same in this concept. So that means further zeros are not possible. Okay, or if you want to apply, that will be on R2, that is R2 plus 2 times R3. So but this step is not being required because we are already having a non-zero rows. So 0, 1, minus 6 plus 6, 0, minus 3 plus 2 times 2, so it will be minus 3 plus 4, that will be 1. So 0, 0, 3, 2, 0, 0, 0 and 0. Okay. So that means number of non-zero rows is equal to 3. Therefore, rank of A is equal to 3. I think the step has been clear to everyone. Now, in the next session, we are going to start with the normal form. In that normal form, we again have to apply elementary transformations. They will be both row and column operations. Okay, that's it for today. Take care. Goodbye.